Okay, so I'm going to stop breaking this lathe down for transport here. I still haven't really started on the shop at the other house, but I still got to get this off here and all apart and start breaking down the bench that's on here. So I figured I had a free weekend, might as well start doing that now. So basically, if you have the old leather belts, you're perfectly fine. You just undo the clipper lacing, if it is a clipper lacing, and pull the pin and separate your drive from the rest of your lathe, and separate your tensioning bar, your lever, and the electrical from here to the motor, or just separate your drum switch right off of there, and you're completely disconnected and pretty much ready for transport. If you have to break the rest of the lathe down into smaller pieces to carry it, that's fine. I have a endless automotive serpentine belt, and I don't want to cut it, I want to reuse this. So I have two choices. I can either pull the shaft out of the drive assembly here, or I can pull the spindle out. So I'm going to pull the spindle out mainly because I haven't shown how to do that, and I'm kind of interested just to make sure that these bearings are good to go. It's been about, I want to say maybe about two and a half years or so since I rebuilt this and did the wicks and stuff. So I'm interested to make sure there's no galling and make sure my tolerances are good, and just make sure everything's kind of okay in there. So basically, what we need to do is just force this spindle out that way. Now this is only for the newer, not that they're new, but the newer Southbends that have the split casting headstock. In other words, they only have one screw in the top and side oilers. Anything that has the two bolts in the top here with a cap that comes off, those require a different process, especially with if you have something like a heavy 10. They're expander screws. You can really screw up your bronze bearings if you don't follow the instructions on how to take those out right. So do not try to do this on anything that has the two screws in the top, and that is not a split casting, a later model A, B, or C. So with that said, we have to draw this spindle out that way. Now some people will tell you just take a block and a soft hammer and just whack the shit out of it and get it out. I can't bring myself to do that. So we have a puller to do it that we made, very simple to make. So you need some things. All you need is just a couple blocks of wood. This is just regular 2x4, and a piece of threaded rod. This is 3/8. Again, it doesn't have to be super heavy duty. We're not putting a whole huge amount of pressure on this to get it out. We're just enough to break it free. 2 blocks with the hole cut in so that the threaded rod slips through, and your threaded rod has to be at least long enough to get from one end of the lathe to the other, and then you also need a spacer of some sort on the front. Now what I have is actually this is an exhaust reducer for a car, and it happens to fit over this perfectly. Now if you look here, if I can zoom in on it, you can see here you have your spindle threads, but then you have this outside register here. You need to make sure that the diameter of whatever you're using as a spacer goes over that, because this entire spindle has to fit through it. So this fits on there perfectly and is just round enough to hit this entire flat spot of metal to give it a nice good grip. Now it doesn't have to be metal or anything like that. You can use a regular piece of PVC pipe, and even that doesn't have to be that thick. You can use a regular Schedule 40. It doesn't have to be any of the Schedule 80 thick weld stuff. And it doesn't have to be super long. In other words, you don't need a piece that's as long as the spindle is, because what it is, and you don't have to take these off to take out the spindle, but it's easier to show you here. What you have is basically what's holding this whole assembly together, besides the take-up nut on the end, is holding pressure against everything. But what's actually holding all these components in, or the spindle from basically moving out, this bowl gear here sits on a keyway inside the shaft. You'll see when I pull it out. and this bolt gear here is press fit. Now obviously you pull the bolt gear pin, this cone pulley is free on that shaft, and then right here, back here, see if I can zoom in a little bit, right here, that is a ball, thrust bearing. So that's basically the makeup of your spindle. Now this bolt gear only has to be broken free from its press fit, so it only has to move maybe about 1.5 inches, 2 inches at most. So it doesn't need, like I said, doesn't need to be super long. This is about 2.5 inches long or so. I don't have a ruler handy. Well, 2.5, 3 inches, and that's more than enough. So I've turned the oilers down and drained all the oil out. You can zoom in a little bit more here. Give you guys a better look. When I stop pulling it, I'll give you a better view of it. But I've turned the 2 oilers down and drained the oil out. You got to take out the screw that holds your reversing gears in place and pull the entire reversing gear bracket out the back. Then take off your take-up nut off the back and your fiber washer or roller thrust bearing if you have one. And set those aside. Obviously take the tension off of your belt. And we'll need to get our Allen here. And loosen our screws. Now before you loosen these, what I do recommend you do is do the lift test real quick to check your tolerances, because when you put this back in, you want to try to keep these to the same tightness as what they were. So you can you don't want a huge change in what you have from before you took it out until after you took it out. So in other words, if you have, say, 1/1000th of clearance in here, you don't want to put it back in with, say, with 2/1000ths of clearance. You want to keep the specification that you have and that you're comfortable with. So I already know what this is, so we don't really have to do that. So we just need to loosen these up. You don't need to take them out, you just need them loose. If you take them out, you may have a tendency to push the shim pack out when you take it, when you pull the rest of the spindle out. So if you leave them in a little bit here, that'll help hold them in place. Now take your block, your threaded rod, put it through one end, take your spacer, and then your other block, and then just a washer. Sorry about blocking the camera here, just put the nut on. And you can see here how much movement is actually in that spindle, and that's what that take-up nut on the end adjusts. Okay, now we're all snugged up. Let me get you a better position and see if we can see this coming loose. Okay, this way here you can kind of see the whole makeup of what it is. There's a block on one end, a block on the other, and we're going to basically pull this block into the spindle and push it out this way. So we get everything loosened up, and we're just going to tighten this, and you'll be able to feel it move. I don't know if you guys will be able to see it. It'll feel really tight, and then all of a sudden it'll give. What you can do too is, if you have a couple pieces of thick wire, these vent holes here go right into your spindle wicks, which are spring loaded. There is a dip in the spindle which can catch those and tear them. So if you take some stiff thin wire that fits in there, you may be able to catch those and hold them down. When you put it back in, you're going to have to do that, but you'll be able to stick your finger inside, compress the spring, and put that pin over the top to hold it. So, again, it's going to feel weird and you're going to feel like you're putting a lot of pressure on it, but it can take it. And like I said, this is a lot more gentle than beating on the other end of it. Alright, right now it's starting to get the pressure. Should hear it crack free in a second here. Got a lot of pressure on there. It's starting to bite into the wood and it doesn't want to move, so I'm going to give it a quick little tap, and it's not even going to be hard and it should pop it free. Let me grab my mallet real quick. Okay, now it's holding a lot of pressure in there. I can feel it, so I'm just going to give this a little tap. I'm not going to whack it, and that'll help loosen it up a little bit. Just got to get around to the other side of the camera here. There it is right there. Just popped free. Now you can see I just barely even tapped it and I just got it to pop free. Okay, we're holding a lot of pressure there. I'll give it another tap. Okay, holding pressure again there. There it is. It just popped off the key, so now it's completely loose. Broke free his press fit. Alrighty, let me just get this out of the way and come right back to it. I gotta get over to the other side. Just had to get that other nut off. Okay. Now this will come right out. Just be aware that you do have a bearing here. Okay. Sorry if I got my shoulder in the shot there. Turn this around so I can see what I'm doing. Alright, right here, this is your ball thrust bearing. I'll get all close-up shots of these. Here is your cone pulley. And your bolt gear. And you can see right there is the key that it rode on. And this right here is your spindle. Now, like I said, I'll get a close-up of all this here. Right here is your bearing surface right here, and your bearing surface is right here. Now, these pretty much look like the way I remember them. I'm just wiping all this off. Now right here is where your cone pulley would ride, and this is the bearing surface. If you had the lathe in back gear, this is where the cone pulley would spin. And so you can see here we have pretty much nice smooth surfaces throughout. You can see wear but no galling. Wear but no galling. This shiny spot right here that looks like a line, I'll show you what that's from. Got a little bit, I don't even think that's galling, I think that's old oil or something on there. Yeah, that's not galling. I don't know if the camera can pick that up, but see those little spots right there? That looks like dried oil, and that is from the edge of the oil groove. In other words, that's the part that's overhanging. Excuse me, sorry, got out of frame. That's the part that's overhanging the oil return groove, which I'll show you what that is. Alright, let me give you a good shot of inside these bearing surfaces here once I get them all clean. Let me go get a towel to wrap this in so I don't scratch it. Now all this is hardened, but still, this is pretty much the heart of your lathe, so you want to protect it as much as you can, especially the threads, which I'll go get my thread protector and put that on if I can. I think I packed it up in a box though, so might just have to wrap it with something. Okay, I got you in close here so you can kind of see the anatomy of what we're looking at. This is your spindle bore and actually your spindle bearing. In these Southbends here, it's just cast iron. There's no bronze insert, there's no roller bearings or anything like that. It's just cast iron. What happens is the oil that you put in those side oilers here, which is just below where my finger is, that's connected to this felt right here, which absorbs that oil. The top of this felt here, you can see it's spring loaded, so it sits down like that. And just by, if I pull it up, maybe a closer look at this here, you can see it's kind of a stiff felt on the top and a softer felt on the bottom, and you can see how much oil I can squish out of there. What happens is that felt on the top rubs up against the bottom of that spindle, draws the oil onto that spindle, and that film of oil actually floats it in this bore. So technically that spindle doesn't really touch this, only on startup and usually on the stop, and the centrifugal force goes down, the oil drains back out. Now what you see, which looks like stripes here and scoring, this is perfectly smooth. I can drag my fingernail over this and I won't feel a ridge. That's normal wear. Even I've seen and heard a lot of people having these lathes and having these scored to hell and back, and all they'll do is stone down the high spots and they'll run them and they'll be perfectly fine. Now you can see this area of the bearing here has a lip on it, and this area is lower. Right here it's raised, and it's pretty much like a V with a low spot right in the middle there. Now what happens is the centrifugal force draws the oil up here, coats that spindle. This oil gets forced to the edge, gets caught in this little channel here, and goes into this hole, which goes back down underneath this felt, and the oil gets recycled. That's why on the newer lathes with the side oilers, you don't have to put as much oil in them as, say, the top oilers, which you put the oil on the top and they just drain out. These will actually hold their oil. Now here's a little thing. Some lathes, some Southbends have these, some don't. And I think they're more prevalent on the segmented bearings. By segmented bearings, lathes that, I believe it's the 6-speed lathes. In other words, when you look at the drive, if it has 2 pulleys for your V-belt, usually you'll have segmented bearings. So what that means is it'll look like this, but there'll be slots cut into it, and that's to draw and use more oil, because that thing's running a lot faster, and keep the oil in this bearing rather than getting it forced and slung out to the edge and just out of the lathe completely. And you'll see these things more in those than you will in these, and they're usually made out of brass, but mine are made out of copper. And what it is, in every drain hole, which there are 2, there's one in the front here and there's one in the back here that you can't see. Same thing on the rear bearing. But you have, let's see if I can get this sucker out of here. And my lathe did not have these, but I did make them. Is this little clip here, and you can see it's just bent down, and with a little loop at the end there. And all it does is it sits down in that hole. That bend in the hole there keeps it from coming back out. In other words, we'll keep it forced down, acts like a spring. And these 2 edges here, I did file them flat. They fit perfectly in the very, very edge of that groove. Now what they're there for, as far as I can tell, is to break surface tension of the oil. In other words, as this oil, especially if you have it on the faster speeds, the oil's getting flung out to these edges. Sometimes it's traveling too fast to hit this groove here and back into the hole. Sometimes it'll just get slung out the lathe completely. You'll see, a lot of times you'll see a drip of oil coming down the front of the back, especially on the rear bearing, because it's about half the width of the front one. Now what these do is kind of break the surface tension of the oil and will slow it down and allow it to hit that and drain into the sump. I was having very bad oil consumption on this lathe, especially on the rear bearing. Once I put those clips in, that helped a lot. The other thing too is, especially when you get these lathes, they're sitting around a lot of them haven't been maintained. You're going to want to pull the spindles out and change these wicks, because they will get to the consistency of wood. They'll get hard as a rock. And also, all these little passages in here, you can see how small they are, will get all gunked up, and then you'll get no oil return. And another important thing too, what people often miss, and will often actually paint over, is right here, there's a vent hole that goes all the way through into that main hole. You can kind of see the rod there on the bottom. You can see that move right there, kind of right there. You can see that. that's a vent hole. That'll also help with your oil return. That you have to make sure you don't paint over that and make sure it's completely clean. And also when you put the spindle back together, you'll use that. You push this down completely. You'll stick this or a smaller one through here and grab the top of your wick to hold it down as you put the spindle back in place. Now, to get this belt off, I'm also going to have to pull this bowl gear. This bowl gear is super easy to pull off. There is a screw right here that you would take out, and let me swing you in place here, just because I'm not going to show this, because they're very rarely are they really stuck. The only thing you do have to contend with is, you can kind of see the top of it right here, is there's a taper pin right here and another one on the handle right here. You have to choose one of them and drive them out. I chose to drive this one out and leave the one on the handle. And this whole rod, once you drive that pin out and loosen the bolt or take out the bolt on the bottom side, it will slide out. Just be aware that this is a tension bolt. There's usually a spring underneath here too, so don't lose that spring. So I'm just going to pull that out, and this bowl gear, this back gear here, sorry, will come right out. Let me set up on the bench and kind of show you the other components of the rest of the spindle. Okay, you can see pretty much here's all the components that we just took out. Now the back gear here, this is the side to the front of the lathe. All I did was pull this taper pin. You can do either one, it's just this one was easier to do for me. Undo the screw in the bottom that holds the spring and the tension shoe, and then unscrew the set screw on this side that adjusts the throw, and then just slide the whole thing apart. Now this was all greased, and I already wiped this off instead of oiled, and you can see there's no wear on there. I mean, this thing is 63 years old, and there's no, I mean, I could scratch my fingernail over this. I don't feel any kind of appreciable difference. There is a color change of wear from here to here, as the inside of this is pretty much hollow. The only parts that touch that bar are from about here over and here over. So, I mean, the oil, the grease rather, does work fine. You can also use the oil. Now here's the bowl gear, and here's that keyway that I was talking about, and that sat on this key right here. Now that is the only part that is actually bonded to the spindle. Everything else just freely floats on this or is screwed to it. When we were forcing everything off, you were not actually forcing this through the bearings at all. The only thing that you were putting pressure on, the only thing that you were forcing off, was the press fit of this bowl gear to this one small section of the spindle. Now you can actually see that this slides nicely right on there, and then it stops right there. Now when you put this all back together again, you're going to reverse the process with the spacer out in the back of the lathe and push it in from the front. But you have to make sure your bearing is going to be covering pretty much this, so you can't see this key. So you're going to have to put a Sharpie line to mark it, and a Sharpie line on the top of this bowl gear here to mark where that key lines up, to be able to line them up. The last thing you want to do is damage this key. Again, you wipe this down because I've been handling it. No appreciable wear to the spindle itself. I mean, you can see striation lines in here, but this is a hardened spindle. There's no melted, a lot of times you'll see galling on this of just the chunks of the cast iron being sloughed onto this. And this is a smaller spindle bearing here. So There's nothing really on here. There's a little bit of dried oil, and you see right where my finger is. That's not galling, that's dried oil. That is a section that overhangs that little oil return groove. So that'll come off with some solvent. And right here is where the actual cone pulley would spin. So this is its bearing surface right here, and again, this was greased, not oiled, and no appreciable wear or galling on that. So the grease does work. Now you'll notice, let me get a good shot inside here. I don't know if you can see. Let me try to get the light the right way. You can see, yeah, right in there. You'll see this large groove right here, this circle right here, that is in line with the oil hole, and these other grooves right here are kind of crisscrossed throughout this entire piece. Those are oil channels. If you were to use oil, that would allow the oil to flow and spread itself around. We use grease, like I said, and there was still a nice coat of grease, albeit dirty grease, in there. I did use the regular super lube. Maybe when I put this together, I'll actually order the correct lube for it, which is from Roy Dean Products. You can only get it online, and it does cost a little much, but we'll give that a shot and see if I can see any appreciable difference. Now the other thing that you do have to worry about is, if for any reason, this here is your ball thrust bearing. This is at the end between the cone pulley here and the rear bearing, and this is what you're adjusting the pressure on when you adjust that take-up nut. Now you don't want to do it too tight, obviously, because it is a ball thrust bearing. The other thing is too, is you do want to make sure that you keep this in as pristine condition as possible. In other words, you do want to squirt a little bit of oil into it from time to time, and just make sure that if you do use grease in this pulley, that you don't use so much that it squeezes out the side and gets into this and follows this bearing. The reason why is because you'll never be able to find this. This is a proprietary bearing. You will not be able to find this in any catalog. The only place you're going to be able to get it is going to be on eBay or from somebody who sells used Southbend parts. So if anything happens to this, you kind of, I wouldn't say completely screwed, but it's going to be a chore to try to find one. There are people that may have this in stock. One person that comes to mind is Ted, Southbend lathe man on the Practical Machinist forums. Actually the guy who I got the large dials from. He'll probably have a few of these lying around, but I mean, you're gonna pay for them, and they're not gonna be cheap for you. He'll probably run you anywhere between 30 and 50 bucks. So like I said, make sure you either A, don't lose it, or B, don't break it. And then your last component on the outside there is that roller thrust bearing, if you have done the modification like I have in one of my other videos, and the take-up nut collar. And that's it. So I'm going to wrap all this stuff here, package it up nicely in a box, and get ready for a move. And hopefully within the next couple of weeks I can actually get to getting the shop all set up and putting the floor and everything in. I'm going to go with some vinyl tile. I'm not going to do black and white like I did here. I'm probably going to do blue and gray. The floor at that house is a little bit bumpy, but you know, I looked into actually getting it all smooth and nice and 100% level. It's pretty level. It's just it's an old concrete floor. It's got a few hills and valleys in it. But it's just kind of cost prohibitive to even attempt to do that, because the self-leveling compound, so it'll cost you about 45 bucks a bag, plus the fact that I would need a lot of bags to do that area. So I'm just going to put the flooring over that and just conform it to everything. So it's going to be a little bit bumpy, but I'll put down some anti-fatigue mats, and it should be as good as we can get it, let's put it that way. And I'll put some lighting and stuff in there the way we need to, and then we'll start working on the electrical, which I'll show you how to do, or how to do correctly. and hopefully I can source a nice 3-phase motor and we can get that VFD hooked up to this lathe and try that out. So those are things for the future, but in the meantime, let me get back to work at the house and see you when we get around to making the next video.